what does it look like to you? It's actually a battery which has energy storage capability inside it. So it's something which is made up of with carbon fibers. So these fibers look like similar to your hairs if I compare it, and they have capability to store electrochemical energy, which means that you can charge your batteries, your mobile, your laptops using these technologies. And if you see this panel is so thin, actually in future you can have your smartphone as thin as to this panel. My name is Richa Chaudhary. I was working on lithium-ion batteries and the recycling of e-waste at NTU Singapore. And then I came to know about an opportunity to work on these advancing structural batteries, which is basically multifunctional structural batteries. So these batteries have several functions at the same time, just like a human skeleton. So they perform multiple functions. So if you compare with the traditional batteries, they are kind of monofunctional batteries. They only store the electrochemical energy. They don't carry any mechanical load. And additionally, they serve only one purpose of storing the electrochemical energy. When you replace these monofunctional batteries with multifunctional batteries, they reduce weight a lot, particularly in sectors like electric vehicles or electric aircrafts or consumer electronics. Every kilogram of weight matters. So if you save some of them, it means a lot. Because you are creating heavy devices, which we don't want to carry. Additionally, you are limiting the performance of the battery due to the heavy weight of your vehicles or the devices. So if you reduce the weight somehow, then you can increase the chances to add more functionality or more electrochemical energy in that. During the initial phase of this research, we have a very strong mindset that this is going to work and this is the way we need to develop these structural batteries. And we strategically took pathways to complete that. When I was working on this research, I was initially developing the structural positive electrode, and lithium is one of the critical components to check the performance of this structural electrode. And the limited supply of lithium worldwide has started, and it was the biggest challenge in my research. It hurdles my work a lot and delayed the deadlines. Another challenge I faced is convincing the people that this is really going to work somehow, because the concept is really new, and telling the advantages of these multifunctional batteries over monofunctional batteries was quite challenging. I find a chance to create a more sustainable future or more sustainable energy storage devices using these structural batteries. Sustainability is really, really important, because when you are using any of the material or any of the device or anything in this world today, you are actually borrowing everything from your children or from your future generations. So if you really don't care of this stuff, then you are going to finish it sometime soon in the future. I envision a very good future of these multifunctional batteries. It's not far away. It will be within few years, then we can see the adaptability of these multifunctional structural batteries in consumer electronics or in some of the devices. We have developed good results at the laboratory scale, and with the continuous development on these technologies, which is progressing faster, we could be able to see very promising outcomes in the near future. It feels fantastic, I will say. It feels really nice when you see that the work you have done is really pay off. It's a very satisfactory feeling. Whatever you have envisioned for a sustainable future, it's really making an effort in real time.